Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ukobela Maths. And without any further ado, let's look at this question that we have here. Okay, so we have question 5 on trigonometry. It says point T, which is -1 and is 2, -2, is given in the diagram below. A is a point on the x-axis such that the reflex AOT is alpha, as given here. Then they say determine without using a calculator the value of each of the following. Now we know the first thing with these questions here, if they give you a halfly drawn sketch there, all you need to do is just add on that vertical line so that this becomes a right angle triangle. Now you will know that if you are given the coordinates there, the x coordinate here will just go to the x value, which is your adjacent side, and then your y value here will just go to the opposite side. Now that means you have adjacent and opposite, so you are looking for the hypotenuse side. So that's r squared is equals to x squared plus y squared. Now your x is -1 square plus a -2 square. Now having to do all this, you will end up having 5. So that means calculating your value for r, your r is √5. And note that your hypotenuse can never be negative, so you just write it as it is there. That's √5. Now, you just have to make sure that everything is filled in your right angle triangle before you start solving these questions. Now that everything is filled in, we can start now solving the questions. We have tan alpha, which we know according to SOHCAHTOA, tangent is opposite over adjacent. So what's our opposite side? That's -2, and our adjacent side is -1. So -2 divided by -1, that's +2. So that's how you have your tan alpha there. Now for 5.1.2, we are looking for cos alpha, which we know cos is adjacent over hypotenuse. So my adjacent side is -1, but my hypotenuse side is √5. Then just like that, you have solved it. Now for 5.1.3, usually the third question from this involves your grade 12 stuff, right? So it's either they can put in a double angle here or they put a compound angle. This time around, they decided to just give us a compound angle. So we are always expecting that because we are used to the trend of these questions. Then cos alpha plus 45 degrees, we know that this is the compound angle for cos. So it says cos alpha, cos 45 degrees. Then remember what happens, the sign changes, and then we have sine alpha, and then sine 45 degrees. Remember the cos alpha you just calculated in 5.1.2. So you just come here, substitute in the value, but then the cos 45, from our knowledge of special angles, we know that it is equal to 1 over √2. And then here I have the sine alpha, which is opposite over hypotenuse. My opposite side is -2, and my hypotenuse is √5. Again, the sine 45 is equivalent to cos 45. So it's 1 over √2, right? Now, if we start multiplying here, -1 times 1, that's -1. And then if we are to use the SAT rule that says if I have √a times √b multiplying, then this can be just put in 1 square root, and then we say a times b, right? So that's what we are using here. We just say all of this will be 5 times 2, which is 10, √10. Then here we have -2 times 1, that's -2, but then we have the negative outside, so that's +2 over √10 still, right? Then -1 plus 2, remember the denominators are the same. I can just deal with the numerators there and express them to the same denominator, right? So that's 1 over √10. Now, you may decide to just leave your answer like that, or others might just decide to say, let me just rationalize the denominator because I do not want my answers to be in the form of an unrationalized denominator. So, okay. So all you do is just take the denominator and just multiply like that. Then this will give us √10 over 10, right? But then you can just leave your answer at this point. You can just leave your answer. Here you are just flexing your maths muscles, right? If you want to rationalize the denominator, that's just you flexing your maths muscles. It is not really necessary. Then, okay, let's proceed to 5.2. It says determine without using a calculator the value of the following expression. We have 2 sine negative 20 degrees, sine 160, and then minus cos 40 degrees. Now we know sine of a negative angle is negative, so we have negative 2 sine 20 degrees, and then this can be written in the form of a reduction formulae as 180 minus 20 degrees. So we just want to make sure that we are working with one angle there. But then looking at cos 40 degrees, we can all tell that this 40 degrees here is a double angle of the 20 degrees. So let's just write it as, so that we can see that, let's just write it like this, cos 2 and then 20 degrees to indicate that it's a double angle. Then at this point, we have the negative 2 sine 20 degrees and then sine 20 degrees. So let's continue writing this as cos 2 and then 20 degrees, a double angle. Then this will give us negative 2 sine squared 20 degrees. And then this is a double angle, right? Now the double angle of cos can be broken down as cos squared theta minus sine squared theta, or as 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. Now, how you break down this is determined by what you have in your equation, right, or your expression. We can see that our expression here in this first term, we have sine, right? So we want to deal with the same trig ratio. So it would be best for us to just change the double angle of cos to this. In that way, we ensure that we are only working with one trig ratio. So now I have negative, and then inside the bracket, because I'll be substituting a whole expression, this will be 1 minus 2 sine squared, and then 20 degrees. Remember, the theta there is for the angle. So 20 degrees like that. And then this will now, at this point, we can see that negative, this one will be positive. So it will definitely cancel out with that. Now we have negative times 1, that's negative 1. So that's our value there. We were just required to calculate the value. So it's a numerical value. So that's our solution, negative 1. And then let's proceed to 5.3. It says consider 3 cos x sine x plus tan x cos squared 180 minus x. Simplify the expression to a single trigonometric ratio, right? Okay, so what we want to do here is just write this 3 cos x sine x, and then at this point we know that the tan x can change to sine x over cos x, right? But then the cos squared 180 degrees minus x, we know that cos in the second quadrant is negative, but then since we have a negative, a square here, that negative will double and then eventually end up being a positive. So actually this is what happens. We know that cos in the second quadrant is negative, like this, but then since we have the square, this is more like having negative cos x square. So if we expand this, this is negative cos x and then negative cos x. So this ends up giving us positive cos squared x. So that's why every time, even if that particular trig ratio is negative on that particular quadrant, it always comes out as a positive as a result of this square here. So always note that. So when we come in here, we're just going to write it as positive cos squared x, because we know it's negative cos x squared, right? Then let's proceed. We have 3 cos x and then sine x. Now we know this cos x will cancel with 1 of the cos x there. So this will be sine x and then here cos x, right? Now if we can just rearrange this, we can see this is 3 sine x and then cos x, then plus sine x cos x. So there is nothing that I did here to change this. I just simply swapped the position so that you can all see that these are now like terms. So this is more like 3 plus 1. So 3 plus 1, that's 4. But then 4 what? Sine x, cos x. Right. But then remember, we are just required to express this to a single trigonometric ratio. This is not a single trigonometric ratio because we still have two trig ratios. But then if we are just to manipulate this, we can say that we can produce the double angle of sine here by simply factoring out the 2, and then we are left with 2 sine x cos x, right? So always have that manipulation in mind, right? They do it most of the time. They can even give you something like this. You need to know how to manipulate this. Just write the 8 in terms of 4 times 2, right? And then now just like that, you can see that you have produced the double angle for sine. So even here, that's what I tried to do. I have the 4. Now I write the 4 in terms of 2 times 2 so that I end up with this. Now this will now give me 2, and then this is a double angle of sine, which is sine 2x. Now this has been expressed to a single trigonometric ratio, which the trigonometric ratio in our case is sine. Then you are done like that, 4 marks. Now 5.3.2, so this was 5.3.1. 5.3.2 says, hence, write down the range of all of this. Remember, all of this, f of x is now equal to, if they say f of x is all equals to this, remember, we just proved that all of this is equivalent to 2 sine 2x. Now, to knowing the range, if we have to consult our trig, our trig function, we know that drawing the original mother graph for sine, then it goes like this. Let me try to draw it here. The mother graph for sine always goes like this, where your maximum value is 1 and your minimum value is -1. So the range for the original graph of sine is y is an element of -1 to +1. But if you were to check this one here, you can see that now we have the 2 here as our a value. Then we know, according to this, the a value there always talks of our amplitude. So if now it is 2, that means this very same graph here has been expanded like this. This very same graph here has been expanded like that. So now that means the maximum value is now +2, and the minimum value is now -2. Right. Now at this point, I can say, what is my range for this f of x? Now the range for f of x is y element of -2 minimum value to +2 maximum value. So that becomes your range because of this amplitude here, right? So I just mainly focused on the amplitude to get my range. So this 2 here is simply telling us that the amplitude now will be 2. So that means the range will start from -2 to +2. I hope it makes sense. So that was just a question on trig functions. Let's proceed to 5.4 now, which says prove the identity cos 3x over cos x is equals to this. So we know always when we solve this one, let's start from the left-hand side, right? And then let's prove it to be equal to the right-hand side. Then we have cos 3x. The cos 3x here can be written. Let's write the cos 3x so that we still have the x there as 2x. So cos 2x plus x. So I haven't changed anything. I just simply wrote this in terms of the compound formula. So 2x plus x is still 3x. And then right here I have cos x. Now having to solve this, I have cos 2x. And then this will be cos x because now I'm using the compound angle for cos. And then here you will have sine 2x and then sine x over cos x. Now it is much simple to change this one because this one only breaks down to the one trigonometric identity, which is always 2 sine x and then cos x. So this one is not difficult to deal with. But then remember, with this one, we cannot change it right away. We still need the confirmation from the other side so that we can change this one, because this one breaks down into 3 different ways. Okay, now at this point, we can see that we will have cos 2x and then cos x minus the sine x, and sine x will give us 2 sine squared x and then cos x over cos x. Now that we have this sine squared x here, this kind of gives us an idea as to how we should break down this one, right? So we can then now decide to say, okay, because we have this sine squared x and then we always try to work with the same trig ratio, let's now break down the double angle as 1 minus 2 sine squared x, right? So coming here, we will have 1 minus 2 sine squared x and then cos x. So always check the 1 here on the other term for the confirmation of how you can break down the double angle of cos. Okay, then at this point, if we say cos x multiplied by 1, that's cos x. Then if we say this multiplied by that, that's negative 2 sine squared x and then cos x minus 2 sine squared x and then cos x. Now at this point, you can see that we have created like terms there, which kind of confirms to us that we are still in the right path, right? So if we just add these 2 like terms, this will give us cos x and then negative 4 sine squared x over cos x, right? So at this point, we can see cos x sort of for that. So we have cos x minus 4 sine squared x cos x over cos x. Now let's look at this. What do you see in the denominator there? We can see that we have the common factor of cos x. Common factor cos x. So if we have a common factor in 2 terms, what do? We obviously have to factor it out, right? So factoring out the cos x, we now have here 1 minus 4 sine squared x and then over cos x. At this point, what do we see? We can now cancel out the cos x. And then we are left with what? 1 minus 4 sine squared x. But is it what we are trying to prove? No. What we are looking for is 4 cos squared x minus 3. Now, how can we further break this down so that we have this cos here? You will remember from grade 11, we had this. If we had sine squared x, we knew that this can be written as 1 minus cos squared x. That's your trigonometry from grade 11. So we can use that same thing here to change the sine squared x. We say 4 and then 1 minus cos squared x, right? Now at this point, we have 1 minus 4. So let's just solve this. Negative 4 times 1. It's 1 minus 4. And then negative and negative, it's positive cos squared x. Now check. This is positive cos squared x. Let's write it here. What is 1 minus 4? That's negative 3. Check. So therefore, no, it's negative 4 times 1. Okay, 4 here. So negative 4 times 1, it's negative 4. Negative 4 times negative cos squared x meant to say it's positive 4 cos squared x. So I will have here equal to 4 cos squared x. Now at this point, we can see that the left-hand side, we have proven it to be equal to the right-hand side. So it is exactly what we wanted to prove there, right? So note that I fold here like that. Okay, with this negative 4 outside there. And then now we have proven that identity. So it was kind of a nice question. And then to note that it's actually 5 marks. Wow, wow. Very stingy with the marks, I would say. But then, you know, it is what it is. Now 5.5 says determine the general solution of x in the following equation. We have 3 to the exponent of 2 tan x minus 3 to the exponent of tan x plus 1. And then at this point, let's just bring the 54 over to this side, because I can see that now this will kind of give us a quadratic format kind of equation. Now, okay, let's break this down. We will have 3 to the exponent of 2 tan x, and then we can write this according to the law of exponent that says if I have a to the exponent of m plus n, this can be written as a to the exponent of m and then a to the exponent of n. So let's write 3 tan x and then 3 to the exponent of 1, then minus 54. Now, at this point, we can see that we are working with something that may require us to use the k method, right? Because we have tan x here and tan x there. So let's just say, let 3 tan x be equals to k. So that means here we will have what? K squared. And then here we have 3 to the exponent of 1 is 3. But then remember the 3 tan x is k. So we'll have negative 3k. Then minus 54. What are the factors of 54? When you multiply them, they're going to give you 54. When you add or subtract them, they're going to give you 3. So we know that it is 9 and 6. The bigger number takes the sign of the middle term, then this one will have to be a positive. Now my values are k is equals to 9 or k is equals to negative 6. But then remember, we were not solving for k, we were trying to solve for x. So we have to then remind ourselves, but k is equals to 3 to the exponent of tan x. So now we bring over the 3 to the exponent of tan x, and then the 9 can be written as 3 to the exponent of 2. This will give us tan x is equals to 2. This side here, we have 3 to the exponent of tan x is equals to negative 6, which we know if we are to solve anything that has an exponent, and then right here we have a negative, this will just be not applicable, because you can never put any exponent number and then you write, and then you end up with a negative value. So once you have a negative value as your solution there, then it is not applicable. And that gives us a chance to only work with this here. So at this point, remember, this is general solution. So we are still trying to get the reference angle. Then this is x is equals to tan. So getting our reference angle is equals to 63.43 degrees. We call it the reference angle. Now, at this point, this is where now we want to find our general solutions, right? So it is at this point whereby we are now calculating our general solutions. Now, looking at what we have here, at this point here, we can see that the value that we had here is positive. So that means we are looking for all the quadrants where tan is positive. We can start with the first quadrant, and then we just go x is equals to 63.43 degrees plus k 180 degrees. Remember that. So do not make a mistake of saying k 360 degrees, because remember, the period for tan is 180 degrees. So you need to have k 180 degrees. But then again, your tan is positive in the third quadrant. So let's find the general solution in the third quadrant. We have x is equals to, remember, in the third quadrant, the reduction formula is 180 plus theta. So that's 180 degrees plus 63.43 plus k 180 degrees. Now, if we add the 2 here, this will give us x is equals to 243.43 degrees plus k 180 degrees. And then we say where k is an element of integers. So that's how you were supposed to find your general solutions for this equation here. So, all right, that's it for our lesson today. Please make sure that you play the video as many times as possible and just try to understand the approach that I took solving this question, So it will be much of a benefit for you to solve this question and just increase on the knowledge that you have, and then also make sure that you are fully prepared for the exams that are coming ahead. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.